Hi, my name is Ross Downing. I'm an Associate Technical Fellow with the Boeing Company. I've been working for many years in the area of product standards and, more specifically, on an effort to move product standards from a paper and PDF-based system to a fully digital system. I'm also currently the leader of the Standards as Digital Data demonstration project sponsored by the Aerospace Industries Association Strategic Standardization Forum for Aerospace. The purpose of this project is to explain what we mean when we refer to standards as digital data, and also to show government and industry stakeholders that there are strong benefits in moving from paper to digital standards management. At the Boeing Company, as with many other companies, the majority of our product lifecycle management data is already in a digital format. The only major portion of our product data that has not been fully converted to a digital format is the data from product standards. Since product standards data comprises roughly 40% of our product definition data, this is a significant gap. This creates data interoperability problems, configuration management problems, data quality problems, and adds a significant amount of cost to our processes. For these reasons, Boeing has for several years been working to move our standards into a digital format. This has allowed us to author our standards data only once and to feed using systems, including document generation, from a single source of standards data. This has also allowed us to digitally encode rules and logic from our product standards into the digital systems in order to reduce interpretation errors and to increase data interoperability. The return on investment for Boeing has been tremendous. The purpose of this video is to demonstrate one approach to authoring, configuration management, and delivery of product standards data in a digital format, and also to show some of the benefits that the Boeing Company has received by moving to digital standards management and delivery. We believe that the benefits to standards developers and users across government and industry will be similar to those that Boeing has enjoyed. We will all benefit from standards data in a digital format from all sources. It is important for all of us to follow a common path so that we can share data rather than to have this technology developed in silos. Boeing is willing to share key technologies that we have developed for standards in order to facilitate moving in a common direction. In this video, we will show some of these technologies to illustrate one method of how this can be accomplished and show some of the benefits of standards as digital data. We hope that this will encourage others to join us and to pursue a common path.
Action.
Hey, Mark.
Hey, John.
Do you have a minute? I got a problem. Maybe you could help me out. I have to get my design into review in 2 days, and I can't find my standard parts in the PDM. Is there a shortcut? I really can't wait a week for those M&P guys to create my part objects.
John, I think you're going to be late. The M&P guys are really busy, and they work to their own schedule. They're the only ones that are supposed to be creating standard parts for PDM.
And I got another problem. I need standard part geometry so I can check clearance between wire runs and my fasteners. Do you know anybody in the modeling group that could do me a favor?
No, sorry, I can't help with that.
You know, I'd rather just do it myself to save time. I know it's against the rules, but what could it hurt?
Well, the PSO modeling group is the only group that creates standard parts for PDM, and if you do it, it's then going to end up costing Boeing a lot of extra money. John, is there a list of standard parts in PDM? I need to finish this design. It's going to take me a week to get part objects and geometry.
Haven't you heard about IPSMG? It builds your part objects on the fly and delivers your CAD geometry directly into your CAD system.
Really?
All that has to happen is the parts need to be on your program authorized list.
That's cool.
No more waiting for geometry, no more waiting for part objects to be built in the PDM, and there are a bunch of really nifty design tools that are built into the system that help you put the details of the standard parts into your design.
That's great. Where do I find this IPSMG?
Let me show you how it works.
Hi, my name is Jay Ednack. I am the technical lead engineer for the Product Standards Organization in data-centric processes and part selection tools. In the following slides, and we're going to be going over some of our processes as well as some of the applications that we're using to deliver that data to the company. Our first example here, our authors use Extensible Markup Language, or XML, to create a basic resource file that can be used to generate a PDF document through the usage of an XML style sheet. We're using XML specifically due to its ability to be easily translated to other software languages that you'll see later. The XML file contains all the necessary information that is specific to that product standard, with a lot of formatting for product standard commonality being brought into the eventual PDF document through the XML style sheet. This same process of authoring is used to produce almost all Boeing owned and managed product standards today. In many cases of product standards, our authoring process stops here. The XML files are then ready to be translated into whatever format they need to be via a XML style sheet and delivered to whatever downstream systems need that information. In the case of part standards, Boeing chose to integrate some other functionality into those same XML files to support activities we were already performing. At the time of adoption for these processes, rule sets were a piece of software that was already being configuration managed to the part standard itself and a logical candidate to be integrated into the product standard as another piece of digital data. The intent of rule sets is to control part number information and validation as well as part number selection. In simple terms, a rule set gives the user two things. One, the ability to get specific data to a part number in a part standard, and two, the ability to obtain a part number by answering questions or describing the part itself. The Boeing proprietary software for producing a rule set and the servers to deliver that data to the systems have been configured in a way to support many clients or applications and currently support systems for planning, design, supply chain or procurement, and post-delivery support. Designers, manufacturing engineers, procurement agents, and airline customers all use data that is generated and managed by way of rule sets, whether they know it or not. Another logical idea when it came to what could be, and now is, present in the product standard XML file for a given part standard was geometric data. Boeing currently has various CAD systems being used throughout its product lines. XML became the answer for storing that generic CAD neutral data and managing that data to be consistent with the product standard itself. With the geometry being the final piece of the puzzle, our organization now has the ability to generate a document, a rule set, and 3D geometric models from a single authoritative source that are all configuration managed together. Similar to rule sets for part standards, creating data based upon other types of product standards is definitely possible and already done today for process specifications. The data delivered from these specification types currently are delivered via wizards. A wizard is a generic term used within Boeing to refer to an accredited application that can provide authority based upon a user's inputs to the application. The data is tagged within the XML files in a way so that the wizard application can access that data and return work instructions, text directly off the standard itself, data, and/or images to the users at the point of use. Some examples of wizards used at Boeing include the fastener installation wizard, electrical bonding and grounding wizard, and the part substitution wizard. But how does our authoring process work, and how do we get the pieces out to the users, you may ask? The answer is through the use of XML style sheets that we maintain as a part of our production system. One publication produces a PDF. One produces a parametric master model that can generate millions upon millions of three-dimensional standard parts. And another produces a piece of software that helps maintain our production data management systems. The picture shown here is a PDF that was generated from the XML file using a PDF-generated XML style sheet. You can see it looks very much like any other Boeing product standard, and it is through the usage of style sheets to keep them all consistent. The next image shows a generic table that was generated using a style sheet that parsed through the XML file to grab the necessary data and outputted that data into a table format to support the creation of three-dimensional standard parts for CAD design. That data can be used to generate a 3D solid in CATIA V5, UG, AutoCAD, etc. The model shown here in CATIA V5 contains all the necessary features of the standard bolt to be used for design practices. The authoring of standards as digital data provides a single source with little to no manual intervention and increases data interoperability for design, manufacturing, procurement, and product support applications. All this reduces those costs by providing data in a way that reduces varying interpretations of product standards, data rekeying, and less human error. In the following examples, I'll demonstrate some common Boeing applications that are using this data in various ways and providing real benefit to the Boeing company. One of the common applications at Boeing that supports many users is the Standard Part Wizard. As you can see, this application allows me to input a part number or part numbers with wildcards, and will return me detailed information about that part or group of parts. This application itself does not house any data, but rather pulls the data from a data source that's tied into standard rule sets that I mentioned earlier. The resulting screen gives me some basic information about those parts in an easily readable format. However, I can now click on that part to retrieve all the data in our rule sets for that specific part or group of parts. This data is current with the part standard itself, since they are literally coming from the same file and published concurrently. And more importantly, a user can use this data as authoritative data for things such as product conformance reviews, procurement authority, and any other case where this information may be needed throughout the company. This application is also available to all partners throughout the Boeing Partners Network and to all airline customers through My Boeing Fleet. Another application at Boeing that integrates a lot of our standards as digital data is the IPSM Gateway, or Integrated Product Standards Management Gateway. You can see here that the IPSM Gateway maintains a list of authorized standard parts, as well as materials, finishes, process notes, and others by way of an authorized standards list. As a user, I can start the selection of a specific fully resolved part number by clicking the Add to Cart button next to an entry in a standard parts ASL. At this point, I can send the part to my CAD session, which I'll show in a few minutes, or I can bring up more detailed information about that specific part number by clicking on it. This mirrors the Standard Part Wizard detailed information page. This application also allows the user to input complete part numbers and verify they are authorized for usage on the program by comparing the part number to the list of standards in each authorized standards list. The system validates that the part is authorized by the program for usage, and if so, allows me to send the part to my cart. The same constraints that exist in the part number buildup scenario exist here, and only valid part numbers per the part standard authorized by the program are allowed to be sent to my cart. Once I get the parts, materials, or process notes into my cart, with the click of a button, I can create those parts in my CATIA session. The part is created in my PDM system and instantiated into my CAD drawing software. My materials and notes are also inserted into my drawing as well. A job that may have taken hours before to model those parts and create those notes now just takes minutes. This integration of part standard data through rule sets and 3D parametric modeling files are pivotal to the interactions of the IPSMG application and the authorized standards lists themselves. They are actually authored and maintained within the Boeing standards as digital data configuration management system alongside the product standards. All this data working together to give a designer the ability to get the right part, how they need it, at the time he or she needs it, helps improve the design and quality of Boeing's engineering. Another example of an application that we create at Boeing for usage for our users is the Torque Wizard. The Torque Wizard itself will deliver the proper torque to put onto a fastener for mechanics. In this specific case, we're going to go through an example of a scenario in which a mechanic might need this value. So for this first question, we're going to answer no. The specification that this is called out on, we're going to say it's electrical process specification, no. The specification in which the torque value was called out on, we're going to specify. And throughout this process, every time I answer one of these questions, we're creating different answers and different possibilities. So we are going to select metal. Our fastener that we're going to be installing is BACB 30NN 12K56, right there. And our nut that we're going to be installing this fastener in is BACN 10Z C12. And we're going to hit go. So at this point, the mechanic will be required to answer a few questions about that installation. So is this a PLI washer, preload indicating washer? No. Does the drawing require the application of one of the following lubricants? Yes. Is the bolt being installed in a hole with a minimum diameter requirement? We'll answer that no. Is the turning from the head specified on the drawing requirement? We'll answer that yes. And is the joint being fastened or phase sealed? We'll say no, and we'll go ahead with that. So after we answer those few questions, the output to the person installing this will give them the minimum torque, maximum torque, and the torque set point to use for their installation. It will also provide the inputs in which they use to answer those questions if they ever needed to go back and change something.
I hope that this video has answered some of your questions regarding standards as digital data and heightened your interest in learning more and participating in efforts to move in this direction. I believe that it is inevitable that the standards community will move to a digital environment. The only questions are, when will it happen and what will it look like? I hope that you will join us in answering these questions.